Hi, class. This is called the standard normal distribution, and we're looking at that bell shape today. And the standard normal, this is important, is it has that bell shape that we've been looking for, and the mean of 0 and the standard deviation of 1. Okay, so the next section will have any standard deviation and any mean, but the standard normal is going to have 0 as the middle. So basically, the mean is at 0, and then you're adding 1, or subtracting 1 for that standard deviation to get, whatever data we're looking for. But what's really cool about this is you can use technology for it. So remember, we said if we're one standard deviation out in both directions from our mean, that picks up 68% of our data. If we're two standard deviations, that's 95. 3 was 99.7. Well, what if I'm 1.2 standard deviations? Well, then I'm going to use technology. So you might see a table on some of your homework. Don't use the table, just use technology. We don't use the tables anymore because it's just easier the other way. Okay, so a couple notation things we want to recognize is we're looking at a z. Okay, so the value that we're at is our z because that's how many standard deviations away you are. So it makes sense that we call that z, right? Because z is how many standard deviations away you are. So we use this notation with the z. So we can say you're between two numbers, right? Z is greater than this one, less than this one, so maybe between here and here or whatever. And you could say z is greater than a certain value, or bigger than this one, or less than this one. So critical value for standard normal, a critical value is a z-score on the borderline of separating between significantly low and significantly high. So remember that that's 2 standard deviations away. This pen isn't writing very good right now. So 2 standard deviations from mean, right, is where you get that significantly high and low, right? Notation. So we have this notation that has the little symbol down here, and that means the area to the right of whatever number's there. So we'll kind of see that notation come in a little bit. All right, so let's look at an example here. I'm going to bounce open StatCrunch because we were going to definitely need that today. Okay. So this first example 1 says, what is the area under the curve with a z that is less than or equal to 0.63 for a standard normal distribution? I tried to give you that little hint with where to go on StatCrunch that I'm about to show you. So we're going to go to stat and we're going to go to calculator and we're going to go to normal because we have a normal distribution. Let me go back to that real quick. Stat, right? Calculator, look at all the different distributions. People start to think like, my data isn't right if I don't have normal. No, there are tons of distributions. Normal is very common. Okay, so start low, go high, go back down. But look at all these other distributions we could have. So don't think that just because we're using the normal that there aren't other distributions. We'll talk about uniform today as well a little bit. So here's what we're looking at. So when we open this, we'll have this shaded region that it's giving us the probability or area under the curve of. And if you look close, it already gives us the mean of 0 and the standard deviation of 1, which is in the standard normal that we're looking at right now. And then you can play around with all the different symbols here and change the numbers. So the first one we have is z is less than, and it always says x, but it's referring to z when you're at 0 and 1. Okay, so we want 0.63. Okay, and then compute, and it has given me that probability there. So here is, I can't point at it. I tried to point at it for you, but you can see on the graph, right, that the red line, when it goes down, it's at about 0.63, and you could see that it's showing less than. So check that your graph is going in the right direction, that you haven't flipped the less than or greater than symbol in the wrong direction. So the answer to this question up here is 0.63. 0.7357, and you usually go out about 4 decimals. So what is the area under the curve for the standard? The area under the curve is 0.7356. Oops, 7357, whatever, either way, then I rounded it up one. So that is called the probability or the area under the curve. Okay, so we're referring to they all add to 1. The whole area adds to 1. So you can kind of see that as a probability. So we could use this to find certain probabilities. Okay, number 2 here says, what's the probability of a z-score between two numbers? So if I go up here to the top, I can hit between, and that will allow me to go between two numbers. I still have the 0 and the 1, and what is it? It's negative 1.1 and then 1.5, and compute. So the probability of this one is 0.7975. Okay, so we can do between up top again. You have the between and the standard, and we can get that probability down there in the corner as the 0.79. So the z's are what you put by the x value, right? So you think of that x as a z, and then your probability is what you get out. So the next one says what z-score gives you a probability of 0.68. So I probably should have worded that a little better. So I'm going to go here and take off my probability and put 6.8 and compute. And you can see that that's about -1 to 1. So I should have worded that a little better so that you would know to use the between section for the probability. What two numbers is it between? But that's here nor there. But so I can see it's between about -1 and 1, or negative 0.9945, which is less than or equal to x, which is less than or equal to, or z in the middle, right? Either one, 0.9945. So I specifically picked one of the numbers that we already know. We know if you're 1 standard deviation out, it's about 68% of your data. So that's one that we've known from the empirical rule, but from before. So you can get those same ones. What was the other one, just for fun? Wasn't it 95? So we know 2 standard deviations out. So that should be about 2 is 95. Okay. And then the 99.7 was, here we go, was about 3 standard deviations out, which is about at 3. So those were our 3 that we estimated. Now we can find the probability between any of them. Okay, so let's look at, let me go back to the full screen real quick. So you can see how fun it is to use this normal calculator. It's pretty easy. I don't think you'll mind it. So the next distribution we're going to look at in this section, we really are focusing on the normal, but is the uniform. We've looked at this. It means like our histogram, basically they were all flat and equal. So a uniform distribution, the results are a rectangle shape, so it's all flat and rectangular. And let's look at kind of how we can find this. So if we have wait times between a subway department schedule and arrival of I did not read that very well, and arrival of passengers are uniformly distributed between 0 and 7 minutes, find the probability the wait times are greater than 5.25. So we're trying to find wait times, so the times that are greater than 5.25. So if we look at this, we start at 0 and we go to 7. Okay, so 0, 1, 2, 3, 4, 5, 6, 7. So our distribution should be somewhat uniform and look something like this. And so think about the way that we break this up. If I just broke it up like this is 1/7, 1/7. I know my drawing isn't perfect, but it's just like when you were younger and you would draw drawings of fractions. If it's uniform across and you cut it into pieces, it's going to be 1/7 for every single section. And we want, see, 1, 2, 3, 4, 5. So we want to be above about 5.25. whatever that is there, 5.25. So the way that we can do that, we know it's 1/7 distribution on every single thing because there's 7 total and each section is going to be 1/7. You don't usually have to draw the little lines in there. I just think it's helpful to think of it that way. So we know the probability is about 1/7 in each 1/7 for each section. And so the way that I can do this is I can see 7 of them go all the way across. So if I could do the probability of greater than the 5.25, this event, then I could take 7 and minus off the 5.25, and that just gives me the section I want. So about here to here, I don't know what that section is. So I'm just trying to think of it. So 7's all the way across, and then I minus that from that, then I can get that little piece of a section. And then I'm just going to times it by the 1/7, which is our probability of each section there. So I'm going to just take out my calculator. 7 minus 5.25 gives me, oops, I put in 5.5, 1.75, right? So this would be 1.75, and then times that by the 1/7, and I get 0.25. So I got 0.25 is my final answer there. So if it's uniform, just if it goes out to 7, it's 1/7. If it goes out to 8, it's 1/8. That's our probability of every section, right? So then you figure out how much sections you have, which was like 1.75 on this one, and then you times that by the 1/7. I think StatCrunch actually has an area for this, but I have never used it. So, what better time than like live on a video? So stat calculators, it does say it has a uniform. Sweet. So let's do to 7. So 0 to 7. Okay. And then we want greater than, right? Wasn't this one times greater? So we want greater and 5.25. Compute. Ta-da. It does do it. There you go. You could do it in StatCrunch for uniform as well. I don't think this one's too bad. I'm going to leave the StatCrunch calculator open for us. So number 5 says, what's the probability of being above a z-score of negative 1.23? So again, I'm in a z, so I need normal. So I'm going to go to normal. And it already comes up with the 0 and 1, and we want above, so greater than 1.2, negative 1.23. Okay, so remember, by the x is going to be the z. I'm going to hit compute, and I get 0.8907. That's an 8. Okay. 6, what's the area between these two? So take a second, and I would pause the video and make sure you can open StatCrunch and do this right. So you can figure out, I probably should have said that before 5, just to make sure you can do it on your own. But you need to go to the between section, right? And put in the 2 numbers that are given there. So this one says negative 0.8089. Oops, I have an extra number in there. I don't know if it's going to let me get that out of there. Yeah, there it goes. Sorry, it's not as easy to use on the iPad as it is on your computer. 0.089 and 1.24. Okay, so then we get 0.4 for this one, 0.427. Well, that's going to bounce that one up, so this will just become 8 here. Okay. Look at this way number 5 is written here, right? They have this here. So this is saying that you're looking at what is above 0.1. So you can do that 2 ways. So it's above 0.1 or you can do it as below 0.9. So we always like to think of it as in our area above that or to the right. So I'm going to put that in. We need to go back to our standard. And so if I see this weird notation like this, it is above the 0.1. So what is greater than the 0.1? And that's your probability of 0.1, right? So it's your probability of 0.1. So that one's a little bit different. So compute, and the z-score would be 1.28. So that is the probability. Okay, so the probability is 0.1. So the way that's written. We'll see that come up a little bit more, just the probability with it under the z like that. A little bit weird to look at, but this is a z of 1.28. So this is a z-score of 1.28. So we could have done it as less than the 0.9 like that, and you would have got the same answer. 0.9 is the probability, but I really want you to think of it as the area above. This is the one I want you to think about, that one a little more, just the area above. Okay, find the indicated z-score. So you're going to see a lot of things like this, where they either give you the Z, they'll give you the picture, and you have to make it, recreate it in StatCrunch. So this one gives us the area under the curve or that probability and wants the Z. So we need to make it look like that. So Z that we're looking for is greater than, right? So we got to keep this one to be greater. And you take this off and put your probability of 9.382. And there we go. It would say a z of negative 1.54. So you can do it from a picture, and they could give you the z as well, and you find the probability, either one. So assume that a randomly selected subject is given a bone density test. Those test scores are normally distributed with a mean of 0 and a standard deviation of 1. Draw a graph and find the probability of a bone density that is greater than negative 2.11. So let's draw the graph. Oh, that's a terrible graph. I hope you're better than me. And negative 2 is way over here, negative 2.11, and you want greater, so you want it to be greater this way. So I'm going to go over here, and we are given a bone density score of negative 2.11. What's that probability? Greater than that, it's 0.985, 26 actually. 26 around, right? Okay, so you could be asked real questions. Now, this section all focuses on the mean and standard deviation being 0 and 1. And then in the next section, we can use any mean and any standard deviation. So a lot of the real world problems will maybe come out a little bit more in the next section. Find the indicated area under the curve of the standard normal distribution, then convert it to percent and fill in the blanks. Oh, okay, about what percent of the area is between negative 2 and 2? 2 standard deviations. So if you have 2 of them between 2, you got to go up to between, right? And this one we should already know what is the probability between 2 and negative 2, going 2 standard deviations out. 95. So it should be around 95. Yep, 0.9545. Because that's one of our empirical rules, one of our rules we memorize, right? So we don't have to memorize these ones, but that is looking at that standard normal. So all of it's done in StatCrunch, and it's fairly easy to use StatCrunch for, right? Let me know if you have any questions.